This beautiful object is the closest brown dwarf to our planet and to our solar system. It's called Longman 16 and it's only about 6 light years away from us. And today's video is going to be all about brown dwarfs. We're going to use Space Engine and fly around looking for different types of brown dwarfs and learn a little bit more about them. Welcome to What the Math. And so this here is the closest brown dwarf to us. It's a very recently discovered object actually, and in this particular game it even has surface, as I discovered in one of my previous videos. You can go on the surface of this brown dwarf and it looks absolutely creepy. It's totally what I would imagine hell would be like if it was somewhere out there. Anyway, so we're going to escape this and let's actually take a look at this. The other thing about this particular star system is that it's actually a binary star system. So not only is it a brown dwarf, but it's actually 2 brown dwarfs. There's another one right here. We can go to it as well, and it looks probably very similar to the first object as well. And here we can actually land on it and see what the surface looks like. All right, so that's about the same. Just as creepy as the first object. So let's get out of here and let's actually talk a little bit about these brown dwarfs. So what are they, who are they, where are they, and why are they as well? Now, originally this was just a theory, just like with black holes and a lot of other objects in the solar system. This was just a theory that someone proposed, and we haven't actually seen any or detected any for many, many years. But in 1975, a person by the name of Jill Tarter actually suggested this term brown dwarf, and he said maybe there's these objects that are not really stars yet and are more massive than normal planets, and he called them brown dwarfs. And so these objects are basically stars that didn't really get enough materials to become actual stars. Like, for example, if I look at this random star right here, you'll notice that basically it's very, very massive, and because of its mass it started fusing hydrogen and it started producing all of this heat and all of this brightness, and this is what makes a star. Now, if it doesn't have enough mass, and if it's just under about 75 to 80 masses of Jupiter, that's when it actually doesn't really become this bright and it turns into something we call a brown dwarf. Now that's assuming that it has mass more than about 13 masses of Jupiter. So anywhere between 13 to about 80 masses of Jupiter, we refer to these objects as brown dwarfs. Now that's a very, very sort of unprecise rule. It's actually not super accurate, as there is actually planets that we found that are more massive than 13 masses of Jupiter. There's actually one called Dennis P, which I'm going to show you in a second if I can find it. Here we go. This right here is actually, even though technically it classifies as a brown dwarf, and in this game it is a brown dwarf as well, NASA classifies this particular object as the biggest planet in outside of the solar system, and they don't think it's a brown dwarf. They actually think that it's possibly just a very massive gas giant that has planets orbiting around it as well, or specifically moons orbiting around it. Now this Dennis P object is technically a brown dwarf, but as of now it's not really classified as one. And it's about 28 times mass of Jupiter, and you can see it's actually a little bit brighter than the Longman 16, and we can actually go on its surface and see what that looks like. Let's land on the object and observe the surface. Okay, so it's basically very similar to what we saw before, but except now it's a different color. It's more orangey and red, orangey, yellow. And so that's Dennis P. And I think what sets these apart from other planets, and basically this is what would make this a brown dwarf as well, and NASA should probably reclassify it, is that at some point all brown dwarfs had some sort of fusion. Now, we're not talking about fusion that stars have, so not fusing hydrogen to produce helium, but here they would usually fuse either lithium, which is very, very common, fusing lithium into helium-4, or they would fuse deuterium, which is a slightly heavier version of hydrogen. And you can see this actually does look like a star from a distance because it is quite bright as well. But it has its own gas giant right here. We can actually try to see what it looks like and what this particular object is, assuming that it's orbiting the brown dwarf. And this is actually really cool. It has its own sort of atmosphere, its own sort of look as well, because the star here is not bright enough to make it warmer, and so the temperature here is actually comfortable 34 degrees Celsius on the surface. But this is a gas giant that's basically orbiting Dennis P. This is what its upper atmosphere looks like. All right, so this is all really, really awesome. So let's actually keep exploring various other brown dwarfs that we can find. Now, in this particular game, you can actually find them by going into this button and then filtering the objects by the type of the... so choose main sequence star and then go by the type. So we classified brown dwarfs as either M, L, T, or Y class. Now, there's no Y in this game because Y is actually really, really dark. We wouldn't be able to even see it. And I think currently there's only like 4 objects that we found that are possibly Y class dwarfs. They're actually really interesting because Y class dwarfs would be colder than Antarctica on Earth. They would have temperatures of maybe like -60, -70 degrees Celsius, and they would be really, really dark. But we can look at these 3. These are actually... these would be the brighter, these would be the medium bright, and this would be the dimmest. So let's start with M class. We're gonna choose M class and focus on something within 10 light years away from us. So stop search again. And so here we go. Let's actually... So you can reclassify these from the dimmest to the brightest. And let's just start with the brightest one. So this right here would be the brightest, and this would most likely be classified as an actual star in this game. If you take a look at it, yeah, so there you go. This actually is called a red dwarf, even though according to our classification on our planet, this is possibly the higher level or the higher mass brown dwarf here, and you can see that the mass of this particular object is about 84 masses of Jupiter. So this is sort of just in between being a red giant and a brown dwarf. And here it's called a red dwarf, but technically this would be not a star just yet. So in this game specifically, all M class brown dwarfs are technically actually stars. Alright, so let's go to L then. Let's look at L stars, or L class stars. And you can see there's only 17 of them in the vicinity. That's because they're actually a lot more rare than main sequence stars. And let's look at this one, L5. This has no actual name, it just has a classification. And okay, so this is actually a binary system. There's 2 brown dwarfs here. One is, oh, perfect. One is M class and one is T class. We actually surprisingly got really lucky here. So let's look at the M class first. Sorry, L class first. We're going to zoom into this object and nothing will happen. All right, that's good. Let's just land on it then. We're gonna land on this object. All right, I may have to just do this manually because doesn't seem to work. Oh, look at that. There's actually 2 planets orbiting around it as well. A hot desert and a what? And a hot Selena, which I think is a gas giant. Okay, so can I land on it now? Please and thank you. There we go. All right. So this is an L class object, and this is what we saw before. This was what I believe Dennis P was. So it looks really, really beautiful, really gorgeous. Kind of looks like a very bright Jupiter in a sense. So here there's no shadow because basically it's producing its own heat, but also its own color, its own light. And usually these objects actually emit quite a lot of X-ray radiation. As a matter of fact, they emit more X-rays than even our sun. But mostly they emit a lot of infrared radiation. So if you were to look at the sky, you would have to use infrared goggles or infrared telescopes to try to detect them. So this is L class, and right next to it we have our T class. T class is basically the next, the much dimmer, much cooler object. This one here is actually, the temperature here is about, where's the temperature? About 1400 degrees Celsius, so it's actually really hot. But this one is only about 700 degrees Celsius and looks a lot darker. So this is sort of similar to Lemon 16 that we saw before. It's a lot more browny. This is actually what we would expect from a brown dwarf, I guess, to look more brown. And the surface here is just really terrifying. Look at this. This is actually like a horrible nightmare. Basically, you have, I don't even know if you can see this, but there's all these spiky looking mountains, but this is actually not realistic because technically this is actually a gas giant, so it wouldn't have this surface. So this game actually makes it a little bit less realistic in that sense because it would really not have this. As a matter of fact, brown dwarfs are very likely to have no solids on the inside. They might just be just like stars. They have like a lot of really circulating gases on the inside. And let's look at some more T objects. Actually, let's try to find the one with the dimmest structure, basically the dimmest possible object we can find. See, there's nothing here. Okay, no T objects. Let's go into 100 light years away from us. They're actually very rare. Or possibly they're not as rare, but it's really hard to see them. Here we go, we found one, WISE. This is actually from the WISE survey that happened a few years ago. And the WISE survey actually found quite a lot of the brown dwarfs and a lot of dimmer objects. So this is a binary as well, but we're looking at this here, T8 class brown dwarf. So let's go to it. And you'll notice that, look at that, it is absolutely black. It's totally dark. Temperature here is 300 degrees Celsius, but it's not hot enough to do any kind of emission. So this would be probably the most terrifying object to try to approach. I think I would be pretty scared. If I was an astronaut flying here, look at that. I cannot even see anything anymore. It's totally dark. There's nothing you can see on the surface. So this is a T-type brown dwarf, and Y-type would be even colder than that. It would still be black, but it would be much colder than that as well. And this has a mass of about 29 times mass of Jupiter. So basically with this kind of a mass, the object would be considered to be a brown dwarf, but it would not actually have any kind of light emission. It would only have infrared emission. And I don't think we can actually enable this in a game, but we can definitely increase its luminosity by using the exposure and see if we can actually see anything. Oh, look at that. It does have a little bit of like an infrared emission that you can try to make it have, I guess. This is by increasing exposure, and that means that it does have a little bit of a red color that it emits from the surface, and this is what the surface of this object looks like. This is more gas gianty than the other objects, I think. Alright, so this is actually really interesting and kind of terrifying, so let's just go back to the original. And what I wanted actually to show you is the first official brown dwarf that we classified and discovered, and it has a name here. It actually is in this game. It's called, I believe it's pronounced Teed, maybe TD, Tidy. I think it's Teed. So Teed 1 specifically was in 1994 classified as the brown dwarf. Even though here it's actually a red dwarf, but it is definitely a brown dwarf. It's in the Nature paper from 1994, and it was found by, I believe it was a Spanish team, Spanish astrophysicists. I don't remember their names, but they found and classified this as the first official brown dwarf. And I think one of the main difference between this and stars is that all brown dwarfs have lithium emissions. They actually all have lithium, whereas most stars, actually almost all stars, don't have any lithium left. They actually burn it really quickly in their early life, and brown dwarfs don't. They actually keep their lithium and they keep burning it really slowly. So many, actually I think all brown dwarfs have lithium, which stars don't. And also, many brown dwarfs, almost all of them, have methane as well, which stars don't have. So, I mean, just look for more really dark brown dwarfs. There's another one right here, I think. It's called WISE something something. Here we go, 2 brown dwarfs found. And this one here is really dark, and the other one is a little bit brighter. So all of these objects do have methane in them, or most of them I think do, and it's really interesting because that's usually a planetary feature. Most planets have, or many planets have methane. No star has methane, but all brown dwarfs seem to have it as well. And the other main difference between stars and brown dwarfs is that stars usually change their luminosity throughout the years. They basically go from somewhat bright to dim to bright again, and then either become black holes or become white dwarfs, so they become really bright as well. But all brown dwarfs, they basically go through the same sort of period of bright to dim to dark to almost invisible. So basically throughout the years, these objects will become dimmer and dimmer and dimmer and dimmer, and eventually just disappear completely. But the coolest thing that these objects have that no star or planet has is something called iron rain. Now, it's exactly what you think it is. It's basically rain that is made out of iron, which is kind of hard to imagine, but because of the pressures and temperatures and the quality of air in here, there's quite a lot of iron, and it circulates throughout the atmosphere everywhere on the planet. So there's no iron core, but it basically circulates everywhere. And at some point, when it reaches upper part of the atmosphere, it becomes solidified and then falls back to the lower atmosphere. So there's something called Iron Rain, which I think is a pretty cool name for a garage band or for your own rock band if you ever start one. But what's really unusual about all of the brown dwarfs is that their size, if you look at their actual size, which is diameter right here, 90,000.6 kilometers, is actually very similar to diameter of Jupiter. If I look at Jupiter now, you'll notice that its diameter is actually even bigger than the brown dwarf. It's about 142,000 kilometers. So all brown dwarfs have a relatively similar size. Even though their mass differs, their sizes are about the same. But obviously it's the mass that differs them from Jupiter and from other gas giants. They have a lot more mass than Jupiter, specifically at least 13 times mass of Jupiter to make them brown dwarfs. And there's actually at least one brown dwarf that I currently remember off the top of my head that actually has a name, and this is right here. It's called Tea Garden Star. Now this is actually an M-type brown dwarf, so in this game it's going to be a star, but it is only about 12 light years away from us, only about 3 times the distance of Proxima Centauri, the closest star, or 4 times the distance. And basically this here is the brown dwarf that actually has a name. It's called Tea Garden Star. It was found completely by accident when we were looking for asteroids, and it was found because it actually moves through our sky relatively fast, even faster than some asteroids. But it is very, very dim, so you wouldn't be able to see it with naked eye, or even with a powerful telescope. It would be really, really hard to see it because it's actually, because it's a brown dwarf, it's actually super, super dim. Now let's actually find a brown dwarf that has planets, because I actually want to finish this video with something relatively interesting. And here is another binary brown dwarf system that actually has something like 25 planets, and we can see them by enabling this. And all right, beautiful. So why am I looking at the planets? And actually, I'm not going to look at the ones that are farther away. I wanted to look at the ones close to this star right here. So let's zoom in on it. And the reason we're looking at them is that because there's actually a hypothesis, or you can call it a theory, is that it's quite possible to have a habitable world, or an Earth-like world, that orbits really close to the brown dwarf. Obviously, this is almost like a star. It has habitable zones as well, and because of that, if the planet is relatively close to the brown dwarf, it might get enough heat and enough of everything else for it to be a habitable world, to be an Earth-like planet. Now, the only problem is that it has to be really close to the brown dwarf, like actually kind of like this planet right here. And look at that, the hot desert here has a temperature of 206 degrees Celsius, even though this, I believe, is, yeah, it's definitely a brown dwarf. What about this planet? Look at that, 77 degrees, awesome. And can we actually go a little bit lower? Warm Terra with a life. Look at that, warm Terra with a life is exactly what I was looking for. How lucky are we in this particular video? This is completely by accident. Actually, can I zoom in here? No, it's a cold desert. This is a little bit too cold. So let's go to this warm Terra with a life, land on it, and find, well, we obviously will not be able to find life, but this right here, ladies and gentlemen, is what I was looking for. This is the hypothesis that many astrophysicists have, that it's possible for us to find planets orbiting brown dwarfs. Obviously, this would be really dark planets, and this is actually the brown dwarf that it's orbiting. And here you can have life, and it has to be in a very specific region of around the brown dwarf. The brown dwarf has to be quite stable as well. It has to have, not enough X-ray radiation so that it would actually destroy things on this planet. But it's possible, and the important part here is that it has to be far enough away from the brown dwarf that it doesn't get enough, or it doesn't get much tidal heating. This is a concept that I've explored in previous videos, where if you're close enough to a massive object, the tides here, think of Interstellar. Remember the tides in the movie that create those waves? Now, it doesn't just create waves, it actually creates a lot of friction, a lot of heat on the inside of the planet that would heat it up so much that it would probably melt or, destroy everything. There would be huge earthquakes, huge tsunamis, and huge everything. And so it would actually be kind of scary and dangerous to live on this particular planet. But in this world, It seems to be far enough from the from this gas giant to create this absolutely awesome, beautiful. Look at that. There's even northern, or I guess southern lights, or aurora borealis, whatever you want to call it, on this amazingly beautiful life with planet with actual organic unicellular marine life. Now the temperatures here are a little bit too hot for me. The temperature here is about 64 degrees Celsius, so it's kind of like the upper limit of what humans can possibly survive in for, like, you know, 10 minutes maybe. But I'm sure, like, on the dark side or somewhere on the polar regions, you could actually establish a colony, and as long as there is enough pressure. And what's the pressure? Does it say pressure? 8 atmospheres. Okay, 8.3 atmospheres. That's doable. You can survive here. Gravity of 0.5 g, so it's about, you would feel twice as light as you do on Earth. And look at that, there's even a volcano. Let's land on that. Is that a volcano? Oh, I missed it. No, come back. Go to the volcano. And so this is what the surface looks like. Very dim, very, very dark, very kind of scary looking again, but there is life, and that's what matters. And so basically this is what I was getting into. This was really the purpose of this video, to explore the brown dwarfs, but to also make you think about that one day maybe this is where we'll actually settle. Maybe this will be where we live. And beautiful. I even found a volcano. This is totally unexpected, and I think I got really lucky by finding this beautiful planet. This volcano even has lava on it, I think. Let's just zoom in really, really slowly. Yep, lava, and it's definitely an active volcano on this planet. I should probably name this. This is a pretty awesome planet I found. Can I name this? I forgot. I don't think I can. I think I need a mod, or basically you have to like manually hack to name these planets. I'm going to name it Brownia because it's a brown dwarf planet and it has a volcano, and it's absolutely awesome. This is actually one of my favorite places I found so far in Space Engine. I didn't really expect this to be a planet with life and looking so beautiful, so gorgeous. Anyway, so that's all I wanted to talk about in this video, and hopefully you enjoyed it. Hopefully you learned a little bit about brown dwarfs and what they are and how they are and why they are, and hopefully you also realize that we can possibly one day live on these planets orbiting brown dwarfs. If you've enjoyed this video, don't forget to like it and also share it with your friends or someone you think may like to learn more about space stuff. And once again, thank you so much for watching. I'll see you guys in the next video, and as always, game you later, and bye bye.